This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 6, Lesson 6, Fits and Tolerances. A fit is the clearance or the interference between a shaft and the hole it goes into. Each part carries a tolerance, and how those two tolerance zones sit relative to each other decides whether the parts slide, locate, or press together. The handbook gives you two designation systems and a set of numeric limit tables, so this is a lesson about decoding a callout and reading a table, not about a formula. We'll define the three fit families, walk both designation systems, then read a running fit straight off the printed table. Concept 1. What a fit actually is. Both the shaft and the hole carry a tolerance zone, and the fit is named by where those two zones sit. If the shaft zone is entirely below the hole zone, there is always a gap, a clearance fit, and the parts slide or rotate. If the zones overlap, you have a transition fit. The finished assembly might have a slight gap or a light grip. If the shaft zone sits above the hole zone, the shaft is the larger part, so it must be pressed or shrunk in, an interference fit. One more axis. Hole basis keeps the hole fixed and varies the shaft. Shaft basis does the reverse. And hole basis is preferred because you hold one reamer size and change only the shaft. Concept 2. The inch-pound system from ANSI B4.1. A fit is a letter class plus a number. RC is the running or sliding family, always a clearance fit, numbered 1 through 9. FN is the force or shrink family, always interference, numbered 1 through 5. And the locational fits, LC, LT, and LN, are locating fits that are clearance, transition, or interference respectively. Watch the direction, because the two families count opposite ways. For RC, a higher number is looser, but for FN, a higher number is tighter. Concept 3. The metric or ISO symbols. Here each part gets a letter and a number. Hole written over shaft. The uppercase letter is the hole, the lowercase is the shaft, and the digit is the IT tolerance grade, where a smaller grade means a tighter tolerance. Reading down the table, you move from loose clearance through the sliding and locational clearance fits, into the transition fits, and finally the interference and force fits. Hole basis symbols all begin with capital H, meaning the hole's lower limit is the basic size. One caution, the same physical fit lives in both systems, but the inch classes and the metric grades are different labels. Never carry a number from one system into the other. Concept 4. Clearance and allowance, and this one follows from the definitions. The handbook prints the designation tables and the numeric limits, but it does not print an allowance formula. Those definitions are basic arithmetic you bring with you. Clearance is simply the hole dimension minus the shaft dimension. Positive is a gap, negative is interference. The maximum clearance uses the largest hole against the smallest shaft. The minimum clearance flips it, smallest hole against largest shaft. That minimum clearance is the allowance, the tightest condition, and it equals the maximum material hole minus the maximum material shaft. Maximum material condition is the limit that leaves the most metal, the smallest hole and the largest shaft. The drawing symbols that call out these fits come from the GD&T lesson, and the stress a press fit creates was week 2. Both cross-references, not retaught. Setup. A half-inch journal runs in a class RC2 sliding fit, and it falls in the 0.40 to 0.71 inch size range. The handbook's table prints the standard tolerance limits in thousandths of an inch. The hole limits are plus 0.4 and 0. The shaft limits are minus 0.25 and minus 0.55. These are deviations from the half-inch basic size, so the hole runs a touch over half an inch and the shaft a touch under. The table also prints its own clearance column, which we'll use to check our work. Find the maximum and minimum clearance, the allowance, and confirm what kind of fit this is. Solve. Part 1. Clearance is hole minus shaft, so pair the extremes. The largest hole against the smallest shaft gives the maximum clearance. The smallest hole against the largest shaft gives the minimum. Both land exactly on the table's own printed clearance column, which is the check. And since the minimum clearance is still positive, the parts never touch. This is a clearance fit, and the RC2 label confirms it as a sliding running fit. Solve. Part 2. The allowance. The allowance is the tightest the fit can get, so it uses maximum material on both parts. the smallest hole against the largest shaft. That comes out to 1/4 mil, which is exactly the minimum clearance we already found. And that identity is the check, because for a clearance fit, the allowance is the minimum clearance. Then decode a metric callout with the same reading skill. H7/G6 is a grade 7 hole over a grade 6 shaft. And the G position drops the shaft just below the hole, giving a sliding clearance fit. No formula. You read the symbol and look up the limits. Traps. 5 ways this bites. 1. In the ISO symbol, the uppercase letter is the hole and lowercase is the shaft. Mix them up and every limit lands on the wrong part. 2. The inch families count opposite ways. A higher RC number is looser, but a higher FN number is tighter. 3. Transition fits can finish with either a small gap or a light grip, so you can't call one until you read the limits. 4. Allowance uses maximum material. Smallest hole, largest shaft, never the nominal size. 5. The handbook prints tables, not an allowance formula. So read the limits and do hole minus shaft by hand. Quick recall. 3 fit families: clearance, transition, interference. The inch system uses RC for clearance, where a higher number is looser, and FN for interference, where a higher number is tighter, plus the locational LC, LT, and LN. The metric system writes hole over shaft, uppercase for the hole, lowercase for the shaft, with a digit as the tolerance grade. The numeric limit tables are in thousandths of an inch by size and class. Clearance is hole minus shaft. Allowance is the maximum material hole minus the maximum material shaft. Golden rule: name the fit, read the printed limits, and subtract shaft from hole. Next up, Lesson 7, Quality, Statistics, Control Charts, and Inspection. You can now decode a fit and read its limits. Next, we check whether a process actually holds those limits. Lesson 7 covers the descriptive statistics: mean, standard deviation, coefficient of variation, the X-bar and R control charts built from the handbook's constant table, and the out-of-control rules that flag a drifting process. Everything's at PEPrepEngine.com. Cheat sheet, worked solution, and a quiz attached here.
The full study guide, with every equation and common exam trap, is free at PEPrepEngine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.